Next time you're at a gas station, take a look at the pumps. You've got regular gasoline and diesel. But imagine for a moment trying to drive a massive Boeing 777 up to the pump. Neither of those fuels would do the trick. Commercial jets don't run on the gasoline we use in our cars. Instead, they run on a fuel you probably associate with antique camping stoves and 19th century lamps, kerosene. But wait, isn't gasoline the fuel we usually associate with high-performance engines? Why would a multi-million-dollar jet engine rely on the same stuff people used to light their homes over a century ago? Welcome to Simple Things Surprising Histories. Today, we're unpacking the surprising science and the hidden history of why airplanes fly on kerosene. To understand this, we have to look back at the early days of aviation. The Wright brothers and the brave fighter pilots of World War I actually did use gasoline. Their planes were powered by piston engines, very similar to the ones sitting under the hood of your car. Even today, small propeller planes still run on a highly refined gasoline known as avgas. But in the 1930s and 40s, aviation experienced a massive revolution: the invention of the jet engine. Jet engines don't work like car engines. They suck in massive amounts of air, compress it, mix it with fuel, and ignite it in a continuous roaring flame to produce thrust. When engineers were developing the first jets, they quickly realized that standard gasoline had a fatal flaw when taken to the extreme conditions where jet engines thrive. The problem wasn't the engine, it was the sky itself. As an airplane climbs to 35,000 feet, the atmospheric pressure drops dramatically. And here is where physics becomes a pilot's worst enemy. Because of the combination of low pressure and changing temperatures at high altitudes, gasoline is far more prone to evaporating and forming vapor than heavier fuels. Under the extreme conditions of high-altitude flight, gasoline's high volatility can encourage the formation of vapor bubbles inside fuel systems. This can contribute to a dangerous condition known as vapor lock, disrupting fuel delivery and potentially starving the engine of the steady fuel flow it needs. Kerosene, on the other hand, is a heavier, thicker oil. It has a much lower vapor pressure than gasoline. Even at the thin edges of the stratosphere, kerosene remains remarkably stable, flowing smoothly and safely into the roaring engine. But the sky isn't just thin, it is incredibly, brutally cold. At cruising altitude, temperatures regularly plunge to minus 50 degrees Celsius. Most standard liquids would turn to a thick slush, but modern jet fuel, which is highly refined kerosene, is specially engineered for high-altitude flight, with freezing points typically around minus 40 to minus 50 degrees Celsius, depending on the fuel type. It continues flowing in conditions that would challenge many other fuels. Then there's the question of safety and power. Gasoline is highly volatile. A single stray spark near a puddle of gas on the runway is disastrous. Kerosene has a higher flash point, meaning it's much harder to accidentally ignite if spilled. Yet when atomized and sprayed under high pressure inside a jet engine, it burns with unbelievable heat. Plus, kerosene is denser than gasoline, allowing aircraft to store more energy in the same tank volume, an enormous advantage when crossing oceans. For an airplane trying to cross an ocean, maximizing energy while saving space is everything. So the next time you look out of an airplane window, remember the humble liquid keeping you aloft. A fuel originally famous for lighting Victorian street lamps is the exact same chemical marvel that makes modern global travel possible. It remains stable in the thin air, keeps flowing through the deep cold, and packs exactly the punch needed to push hundreds of tons of metal safely across the sky. If you enjoyed this flight through aviation history, make sure to hit that like button, share this video with a curious friend, and subscribe to Simple Things Surprising Histories for more incredible stories hiding in plain sight. Thanks for watching, and we'll see you next time.